You've probably heard this a million times in any discussion about our climate. Hey, the Earth's climate has always changed. And you know what? That's 100% true. It's a core fact about our planet. But that fact also raises a really important question. So let's really dig into that. To get why today is so unique, we've got to look back first. What did natural climate change actually look like, and what was pulling the levers? Okay, so let's zoom out, way out, and look at our planet's natural heartbeat. For hundreds of thousands of years, Earth has been following these pretty predictable, super slow-moving climate cycles. What's so wild here is just the enormous timescale. For a million years, the planet swung back and forth between these long, deep ice ages and these short, warm spells. Then, after that last ice age hit its peak about 20,000 years ago, we entered the Holocene, this amazing period of climate stability. That's what allowed human civilization to really take off. But then, look at the very end of that line. See that sharp, almost vertical spike? That's us. That's today. It's a total break from the pattern. Now, the natural pacemaker for these huge, slow shifts are called Milankovitch cycles. You can think of them as the slow, steady drumbeat of Earth's climate. These predictable wobbles in our planet's orbit gently nudge the climate one way or the other over these vast stretches of time. They set the rhythm. But today, a much, much faster force has jumped on stage and is just drowning them out. And when we say slow, we really mean it. To give you a sense of that pace, the last really big cooling event, a 4 degrees Celsius drop that sent the world into an ice age, took thousands of years to happen. Just hang on to that number, and especially that timescale. It's our baseline for what natural speed really looks like. And that brings us to today, because we're about to see why the speed of the change we're seeing now is the single most important part of this whole story. For almost a million years, the Earth kind of had a rule, a ceiling. CO2 levels would go up, and they'd go down, but they never ever went above this number, 300 parts per million. That was the natural limit. And today, we're way up here, over 430. We haven't just broken that 800,000-year-old ceiling, we've completely shattered it. You'd have to go back millions of years in the geological record to find CO2 levels this high. So, this is the absolute key. It's not just the amount, it's the velocity. When the world was coming out of the last ice age, a huge, natural jump in CO2 took thousands of years. We've managed to do a similar jump in just 250 years. That's the difference between walking up a gentle slope and literally falling off a cliff. And that incredible speed has a direct, measurable consequence. The result of that rapid-fire injection of heat-trapping gas is this. We've already warmed the planet by nearly 1.5 degrees Celsius. In geological time, that's the blink of an eye. And look, we know this isn't some weird fluke because the evidence is coming at us from every single angle. Just look at a calendar. The 10 hottest years ever recorded have all happened in the last decade. Look at the atmosphere. The famous Mauna Loa curve shows CO2 just climbing and climbing. And look down from space. Satellites confirm the basic physics. More heat is getting trapped on Earth than is escaping. This quote really just nails it. If you think of CO2 as a primary control knob for Earth's temperature, well, human activity is cranking that dial at a speed that completely dwarfs those slow, natural forces that used to be in charge. So what does this all actually mean in the real world? This isn't just about numbers and charts. This rapid change has very real consequences, and it's creating this complex map of winners and losers all across the globe. And this table shows that unevenness perfectly. In the winners column, you can see some, localized benefits. Longer growing seasons way up north, new shipping routes opening in the Arctic. But then you look over at the losers column, and those impacts affect way more people, and on a much more fundamental level. We're talking about tropical regions facing drought, coastal communities threatened by rising seas, and declining harvests for the world's most critical food crops. The sheer human scale of this is it's staggering. Right now, about 3 billion people, that's almost 40% of everyone on Earth, live in places that are highly vulnerable to these impacts. That fact alone makes this one of the most significant challenges we've ever faced. Now, a challenge that huge requires solutions on an equally massive scale. And this is where the story takes a really fascinating and, honestly, a pretty hopeful turn. It's all about economics, because the financial landscape around climate and energy, it's been completely transformed in just the last few years. This right here, this is the tipping point. As of 2022, a mind-blowing 86% of all new renewable energy built around the world was actually cheaper than generating power from fossil fuels. Let that sink in. Clean energy is no longer just the clean choice. In most places, it's now the cheapest choice. And this is happening right now. The switch to renewables saved the world over $500 billion in fuel costs in a single year. To put that into perspective, that's more than the entire annual budget of many countries, saved in 1 year, just on fuel. Because of all this, the entire economic consensus has flipped on its head. For years, some argued it might be cheaper to just let the world warm up. But updated models, ones that finally account for the true costs of climate damage and the incredible drop in the cost of solutions, they show the exact opposite. Today, the most economically optimal path, the one that leads to the most global prosperity, is taking strong action to limit warming.
So, where does that leave us? We get the problem, we see the real-world consequences, and we understand this new economic reality. Now, it's all about navigating the path forward with a clear head.
I think the best mindset for this is something you could call balanced realism. This isn't about panicking, and it's not about pretending there's no problem. It's about looking the very real risks square in the eye while also recognizing that we have the tools, the tech, and the ingenuity to actually manage them. And this path forward isn't some big secret. It has clear, practical steps. First, you act to limit the warming itself. Second, you invest in adapting to the changes that are already baked in, making our communities more resilient. Third, you hit the accelerator on that clean energy transition that we already know is cheaper. And finally, you keep supporting the science that helps us sharpen our focus and get even better at this. Ultimately, the choice really comes down to a simple calculation. The cost of acting now, of investing in clean energy and adaptation, yeah, it's significant. But it is dwarfed by the projected cost of doing nothing, the cost that comes from more extreme weather, health crises, and massive disruptions. So yeah, the Earth's climate has always changed, but we know what's different this time. The cause is us. The speed is like nothing the planet has ever seen. And for the very first time in Earth's history, the species that's driving the change is actually aware of what it's doing and has the power to choose a different path. The question isn't what's happening anymore. The real question is, what are we going to do next?